Welcome to another episode of How It Works with Holger. Today we're going to look at something that helps you to find out all about your objects at runtime. And more formally, I could call this episode How to Use RTTI. RTTI, you say? Well, it stands for Runtime Type Information. Runtime being the key here, because at design time, you use the object inspector and you can configure your objects or you write code to modify your object instances, for example. RTTI allows you to find out all about any type inside of your application. That means classes and other types like records, for example. But in addition, it also allows you to interact with these types. Interact, you might ask? Yes, you can look if there is an object instance of a certain class and look at its properties, look at its methods, change properties, and even invoke methods. And that is the reason why RTTI is somewhat of an advanced or intermediate topic. It's definitely not a beginner topic, but I challenge you, because I think if you watch this video, you're not going to say this is difficult. You're going to say, well, it's not that difficult. It's actually quite easy to look at what's going on at runtime in my application. And the reason for that is that Delphi introduced a great new library, I should say, using the RTTI context, which makes it very easy to get runtime information for your applications. In order to get started with RTTI, I prepared a very simple example. And this example is going to show all the types that exist in your VCL application that we're going to build right now. And you might think this is a lot of work. No, it really is not. It has gotten really, really simple. And to take you the fear, we're going to build it step by step. And while I built this, I will give you alternatives, like not only doing what will be the end result of this application. No, I will show you a couple of other properties, a couple of other methods that are accessible. So you, after watching this video, will be able to tinker a little bit with this example. And also a little bit of foreshadowing. I'll do one more video that goes into a little bit more detail and do other stuff, like, for example, invoking a method from something that you found using RTTI. So the form that I built, the main form, just has a memo control and a button. I didn't even bother to rename the button. I could do that. Let's see, button show types, like so, and implementing the button click event. I'm not going to bother using other methods. I always include date utils. That is something, but what is really, really important is you need to include RTTI. That is the new, I don't want to say something wrong, but I think it's a rather new unit, because the RTTI is actually rather old. It was available in Delphi 2 for sure, because I started with Delphi 2 and there was RTTI technology. However, in one of the later Delphi releases, it became possible to use the so-called RTTI context in association with a type, which is called t-value. T-value, you see it right here. I might do a different episode on t-value because that data type is so interesting. However, just for the sake of it, let's focus on RTTI and how to find out more about the types that are being loaded inside of your application into memory. And to get access to this space, as I think of it like there's all your objects in memory and you want to get a list of all those objects. And your door to this is the RTTI context. So we define var and L context is of type trtti context. And hopefully code navigation will let me show this to you. This is a record, and meaning the create is not really a constructor. It's a class function and it returns a RTTI context. If you read the book from Nick Hodges, he uses get type right away. He doesn't bother calling create. He uses get type right away to get information about classes inside of the context. The documentation from Embarcadero recommends using create and also calling free. And the reason for that is that this RTTI context makes sure that it's only created once and not multiple times. And that kind of technology, so to speak, is hidden behind calling create and free. So we're going to follow the documentation and say context is trtti context.create. That gives us our instance. Try f tab context.free. Even though these are not constructor and destructor, Embarcadero decided to use this terminology. I like it. It makes using the context rather natural, as if it were a class, but it is not. It's a record. And then, for example, using code completion, lcontext dot, you get all the wonderful things that you can do with the context. You can get one type using a pointer, get type using a class of type T class. What is that? Well, each class in your application also has a class type. So you could say get type self dot class type, which is of class T class. So that would yield all the information about the class that you're using right now. But it gets simpler than that. For example, if you look at the other things that are available, you can do get types, which gives you a list of all the types inside of the context, meaning those are all the types that are loaded in memory right now. You can also do find type with a string. That allows you to look for a type using a string. And this is also one of the things that RTTI makes very, very easy. If you want to write dynamic code, you can literally have the user enter some string, and that is something you look up in memory. And think of scripting and other stuff like that, or dynamic code execution. And the RTTI context makes this all very simple. There's also get packages, which gives you a list of all the packages that are available right now. So that's what we're going to use. And the return type is tarray of trtti package. And this is really sweet. No matter what you use, the RTTI unit has types for all the different things that can be in memory. For example, a package, a class, even lower down, like not only the class, but also the method, the property, all of these have RTTI types, which give you more information about it. So let's say you get a list of all the packages inside of your program right now. So you would assign that to a variable help packages, for example, and that has to be of type, we guessed it, help packages is tarray of the RTTI package. And with modern Delphi, we can say foreign help package in L packages that iterates all the packages. So L package is actually of type trtti package. Good. This is, by the way, where the discussion is always if it makes sense to use var here, because in later Delphi versions, this automatically declares L package as a variable, so you don't have to use it here on top. It also deducts the type automatically because we know that L packages is an array of trtti package types, so this will be defined as trtti package. In this case, I think it might even be nicer, but to make sure that this code compiles with older Delphi versions, I'm going to use the more older, straightforward approach. So L package now is a package. it gives me information about a package, okay? And again, inside of this package, I can now use get types to get a list of all the types that are defined in that package. That makes RTTI so great. You can literally iterate all the packages, all the classes, or find a certain package, find a certain class. It is all very, very easily to access. There's also the name. So let's just say name and add it to the memo field. So txt results is the name of the memo field that's on the form. Add lpackage.name. So we iterate all the packages that we found and print the name on the memo control. Let's run it. Click show types. Yeah, that is the package. The package is the executable. I don't load any other packages. My executable is the only package, and that's its name. Okay, and now I could keep going in the package. I could say add a line here, and then get the type. So I could say L types is L packages dot get, L package dot get types. Will get all the types that are defined in there. Attribute gets all the attributes. Get interface gets a certain interface. And all these things are possible defined for the package that I use. We list one package after the other and then list the types. So L types. So T array again of type T RTTI. And it really is called like that, type. And a type can be a class, for example, a record. L type is T RTTI type. And L types is L package dot get types. See, it's an array of RTTI type, get types. And then we can, just like we did with the packages, we can say foreign L type in L types do txt results dot lines dot add. And let's see what L type has to offer. It has a qualified name. You can query if it's a public type. What type is it? What's its size? Is it managed or not? That is, oh yeah, interfaces, of course, would be relevant if it's managed or not. If it has a certain name, true or false. And then you can get the methods. You can get the fields. You can get the properties. You can get one method with a certain name. So you see, anything you might desire to get to know about the things that are in memory can be queried. You can even say, is it an instance at all? Or is it an ordinal type? Is it a record? And then you can also cast to that and get more information for that particular type, for a record, for a set type, and these kind of things. It's really, really good. But the name, again, is the most interesting that we will use here. But also, look, we can get for that type if it has certain attribute set or not. If it is, you can also create a package that a certain type belongs to. So you look for a type and say, hey, does it belong to this package, that package? You can also get the parent, which object does it belong to? The amount of information that you can inquiry is amazing. Inherits from, you can question, does this class inherit from another class, for example? It is really, really good. You can also get addresses for the methods. Everything is there. That's it. From short overview of code completion. And let's just do the name. And here we miss a semicolon. That's why we see the error there. And with that, we quit the previous, start it again, show types. And it takes a while. There's a lot in memory that we don't realize. So even an empty BCL application has quite a lot of things that are in memory. Of course, like think about it. So here's the executable, and the first thing it finds is the main form. And then we have all these things here, all the types that are inside of an application. Yes, these are all types, of course. So it's not only restricted to classes, we list everything. Here's the T array, generic arrays, and then even constants like H, W, and D, H, oh, and these kind of things, and then the VCL classes, T border icon, T border icons, T close action. We all know these. They're all in memory, and RTTI finds them. Let's add one more thing that we just want to list objects or classes. So let's say ltypes dot, ltype dot, let's see, we have a qualified name, we have a type kind. That might be something we can look into. Or is there anything else? We have a base type, instance. I think the best thing to use in this case really is to see kind. What does this yield? A type kind. What does it give us? So t-type kind is of system, t-type kind. Oh my God, Delphi. So here you go. You can actually look up if it's unknown, if it's an integer character, enumeration, float, string, and of course, class. And that is exactly what we want. We only want to list classes. So we can say if type kind is tk class, then list it. So let's go here. Let's say if ltype type kind equals tk class, then again. So now only classes will be listed, hopefully. And there you go. This is only classes, and they all start with a T form, T custom form, T title bar. And if you're surprised how many it still is, yeah, it is still a lot, but we filtered out like stuff like integer, Boolean, no longer show exceptions, exception, and all the derived exceptions, they are all classes, of course. So hopefully I've taken away a little bit of the scare of RTTI because it's really not that big of a deal. Use this construct to get started with it. Declare first, use RTTI, step number 1. Step number 2, declare your context. Step number 3, create the context. And step number 4, free the context. And what you do in between is the fun part. It's the tinkering. Because here, you can literally do anything. You go into your context, say lcontext dot, and then you try get type, get types, iterate the types, look for packages, these kind of things. Just try to get a feel for it. And then you will get to know all the different types that the RTTI has to offer. For example, now we found out that we have a class. And a class has properties and methods. So let's list all the methods. And that's the final thing we're going to do. Our methods is T array of, well, TRTTI, you might have guessed it, method. Those are all the methods. And L method is TRTTI method. Perfect. So here we say L methods is ltype dot get methods. Boom. And then we say L method is da da da. So we iterate all of them for in L method, L methods. So one method in all of the methods. Very difficult word for me, I guess. And then we can say again txt results dot lines dot add L method. And let's look at those properties. Methods have parameters, so you can get a list of all the parameters. Methods, sometimes, if their functions have return type, you can get that return type. All of these things you can get if it's a constructor, if it's a destructor, if it's a class method, if it's a stat. The whole world of the things that are inside of your applications is accessible through this context. And that's what makes it so powerful for all things to find out that are going on in your application. So this is it. So this should print the name of the method for all the classes. Let's see. Oh my God, here we go. Takes a long time, lots of methods. Okay. Still going. Okay, here we are. It took a long time, I have to be honest. And one final thing so we can distinguish the methods easier. I'm going to do this. And also, I'm going to introduce a breakpoint of some sort because there's a lot of methods and a lot of classes. So we do count integer. I'm going to set the count to 0 right here. And then we increase the count. And at the end, I'm going to say here, I'm going to increase the count only if it is a class. And if we found 10 classes, if count, make this count, if the count is bigger than 9, that means we printed 10 of them. Or 8 because we started at 0, I guess, right? Yeah, so we said begin, break. That's it. So this should give us a faster output than listing all of them. See, that was only 10. So one more thing, we add the name of the type itself. So txt lines add type dot. Let's make it a qualified name so you see the difference to that. Start types. So here we go. We scroll down. We can't use the mouse wheel. So, and if you're annoyed by that, just like I am, go to your memo, and then you can say vertical scroll bar. That's the key thing to do. So scroll bars, vertical, and if we start it now, I think the mouse should work. Almost certain. See, now I can scroll with the mouse as well. And here we have the tNoRefCount object, interfaced object, and tInterfaced object has these methods, all of them. Cool, huh? So also inherited methods, of course, are listed. So looking at t4main, the qualified name, of course, includes the unit as well. So umain.t4main is the qualified class name. And here's actually my event. Then here the standard stuff from tform. All of it is in there until the next type at some point starts. You see there's dozens of properties. TObject, of course, is a class that is being loaded, and these are all the methods from TObject. So this already shows the power of RTTI. I'll do one more, how it works with Holger next, that will give you the ability to invoke methods from the RTTI types so that the user enters a string and that is being executed. Just in brief, but I'll explain it in detail in the next episode. So thanks for your interest in this particular episode. And as always, give us a thumbs up if you like it. And also, please, please, please write comments if you like this, if this was too advanced or if this was just as you liked it, with the possibility for you to tinker afterwards if you like this as well. So feedback is always welcome. And this episode has actually been created because one of you messaged me and said, hey, why don't you do an episode about RTTI? And here it is. So without you giving me feedback, you'll never see your dream episode covered in How It Works with Holger.